Hello friends, good evening. Friends, in today's video, which is numbered as video number 206, we are going to learn about the projection of a triangular pyramid. And in all such problems on the pyramids or any solid, you have to go through the problem thoroughly and learn how the object is to be placed initially. So the question for today's video runs like this: a triangular pyramid of base 30 mm and axis 60 mm. So the problem has got a base, a triangular base having 30 mm side. So all these sides measure 30 millimeter each, and the height of the pyramid is measured from the vertex, the tip of the pyramid, till the center of the bottom face. So that's called the height of the solid or length of the axis of the solid. It rests on HP on a corner of base. Friends, initial placement of the object is very important. Generally, in all problems on the solids projection, there will be three positions: the initial position, the first tilt, and the second tilt. So if you go wrong in the first step, the all other solutions will be wrong, and the students will not be awarded any marks for that. And hence, friends, let us see how the object is on HP on a corner of the base. So friends, it has got three corners, 1, 2, 3, or A, B, C. So whenever it has to rest on a corner, one of the corner of that base of the pyramid should come to your right side, to the right side of the observer. So friends, this is applicable for all pyramids. That is, whenever any pyramid has to rest on a corner or it has to rest on a slant edge on HP, or the slant edge is inclined to HP, or slant edge is vertical. So for all these positions, the object has to be placed on HP such that a corner of its base is to the right side of the observer. So in today's video, we have the triangular pyramid, and we will write down the top and front views of the pyramid to the given dimension such that one of the corner of this is to the right side of the observer. So we have XY line, and here I am going to write the top view of the pyramid. So top view is going to be a triangle here with the center joined to all the corners, and it has a dimension given as 30 millimeters. Means every side of the base has got 30 millimeter dimension, and we have to obtain here the center of this by bisecting any two adjacent sides. So if they bisect these sides, they meet at a common point, we will call it as O, and that has to be joined to all the corners. So OA, OB, and OC represent the top view of the slant edges of the pyramid. Friends, we will obtain the front view of the solid by projecting lines from all these corners. And here, friends, A and B lie on the same vertical line. So you will get A dash, B dash, and this is point C dash. We have O here. From O, we are going to write a vertical line, and from the base, that is this line on XY, we are going to take the height equal to 60 millimeter. Length of the axis or the height is equal to 60 mm, and I show this 60 millimeter perpendicular to HP. This is the height of the object. This is O dash, the vertex of the solid. Join O dash to all the corners of the base. So we join O dash to A dash, O dash to B dash, O dash to C dash. So this is how the object looks in the front view, and this axis O dash O1 dash is perpendicular to HP. Friends, remember, whenever any of these solids like prisms, cones, cylinders and pyramids, they rest on HP, on HP on their base, the axis is always perpendicular to HP. It is resting on HP on a corner of base such that the base is normal to HP. So we should know what is the base of the solid from this position. Friends, you know the line A dash, B dash, C dash on HP or on XY represents the base of the pyramid, and this base of the pyramid is in contact with HP, and hence it is not making any angle with HP. So friends, he says base is normal to HP. That means whatever the line A dash, B dash, C dash representing the base has to be redrawn, or the whole figure is to be redrawn such that A dash, B dash, C dash becomes vertical. So friends, if we call this figure as 1, this figure in the front view, I am going to redraw this figure with this A dash, B dash, C dash of length equal to so much, and this becomes A dash, B dash, and this point is C dash. We can locate this axis and obtain the corresponding front view when redrawn at an angle of 90 degrees of the base. So friends, we are going to get the front view redrawn with A dash, B dash, C dash equal to the same length base, and this is our O dash, this is O1 dash. Friends, what is that we have done? We have redrawn figure 1 as figure number 2, in which the base of the solid is drawn vertical. Our base of the solid is perpendicular to HP. How do you get it? Suppose this is the way the object is held, and here I am going to make it to raise. This is the base you have got like this. That is, this base of the solid ABC has become vertical or perpendicular to HP. Friends, now let's see what is the corresponding top view for this. It is very simple. Draw projectors from all these points in the front view. Get these one by one. You see here A dash, B dash and C dash. All the 3 points lie on this vertical line. So draw a vertical line from A dash, the horizontal from here. The point of intersection will give you A. Likewise, B dash, vertical from B dash, a horizontal from B. The point where those two intersect is the point B. Finally, C, vertical line from C, the horizontal from here. The point where those two intersect is point C. Friends, if we join A, B and C, this line will represent the base of the solid of the pyramid in the top view. So let us get this point O, draw a vertical line from O, a horizontal line from here. The point of intersection of these two will give you O, the vertex. So join the vertex to all the corners of the base. So we will join O to A, O to B and O to C. Friends, just observe, if you are looking from the top, the edge O dash A dash, O dash B dash are visible, and hence I have shown them by dark lines. Whereas the slant edge O dash C dash, which is covered by this, like this. So this edge O dash C dash, which is shown here, is not visible from the top. So hence this I am going to show by a dotted line. That is, this is not visible to the observer. Friends, this is the corresponding top view when the base of the solid, this is the base, is perpendicular to HP. Base is perpendicular or normal to HP. Further he says, this is parallel to VP. If you observe the base, in the front view it is perpendicular to HP. In the top view, if you observe, the same base ABC is again perpendicular to HP. That is, this is perpendicular to VP. So friends, you observe, when the object is resting on corner C, the base is a straight line in both front and top views, and in both the cases it is perpendicular to HP and also perpendicular to VP. But he says it has to be parallel to VP. So friends, if you call this figure as figure number 3, I am going to redraw this figure, the top view, such that this ACB, the base, becomes parallel to VP or a line horizontal. And friends, remember, since this AB is 30, this length remains 30. And again, I am going to rotate this figure 3 such that ACB becomes horizontal. So friends, anywhere below this, I am going to draw a line of length is equal to this ACB, which is again equal to 30. So this is ACB. If you keep like this, it will become BCA. So this is B, lost is A. Exactly in the center, you get the point C, BCA. This BCA is redrawn. So through C, you will draw that vertical line. And friends, this figure will represent the top view of this drawn at an angle or rotated through an angle of 90 degree. We will call it as figure number 4. And friend, this figure is the final top view of the pyramid. So after obtaining this, let us see how to obtain the final front view of the solid. Friends, here you can see A and B are on this line. So to get point A dash, draw a vertical line from a horizontal from A dash. The point where those two intersect will give you A dash. Likewise, friends, B is also on the same line. So draw a horizontal line from B dash, a vertical line from B dash. The point where those two intersect is the point B dash. So you have got A dash, B dash, one of the base edges of the solid. Finally, C, friends, draw a vertical line from C, horizontal line from C dash. The point of intersection of these two lines will give you C dash. So you have got A dash, B dash, C dash. And what about O? The vertex O is here. So draw a horizontal line from O, a vertical line from this O. The point of intersection is here. So this is the vertex in the front view. We'll call this as O dash. And O1 dash will also coincide with that. So write down O1 dash also. So O dash comma O1 dash. Both are here. So friends, I have to join this vertex O dash to all the corners. So O dash A dash is one slant edge, O dash B dash is the second slant edge, O dash C dash is the third slant edge. And when you join these corners, A to B, B to C, let's see what you get. So A dash B dash is one of the edges of the bottom face, that is the base of the solid. B dash C dash is the other edge, A dash C dash is the other edge. Friend, we have got all the three edges, A dash, B dash, B dash, C dash, C dash, A dash, and all these slant edges. O dash, A dash, O dash, B dash, O dash, C dash. Friend, if you observe here, the object is resting on corner C, and these two surfaces, namely that is C dash, B dash and C dash, A dash, make equal inclination, say alpha with HP. So this will give you the front view of the pyramid. Finally, you have the top view, and hence we obtain the complete solution for the given question. Friends, I hope you are happy with the presentation I have made, and if so, do subscribe to my channel, give a liking to my video, and share this information with all your friends and well wishers. Good evening, friends.